Welcome to the Explainer. So you've probably stared at your data and wondered, should I just cram this all into one big box, or should I create a whole bunch of connected ones? Well, if that sounds familiar, you're in exactly the right place. Today, we're going to dive deep into the core strategies of data modeling in MongoDB, so you can make that choice with total confidence.
All right, here's our game plan. We're going to start with the core philosophy. What makes MongoDB tick differently. Then, we'll get tactical and explore the two main strategies, embedding and referencing. After that, we'll figure out how to choose between them, and we'll finish up with some seriously cool pro-level hybrid patterns.
So, if you come from the world of relational databases, you know the number one rule is normalization. The goal is to hunt down and eliminate data redundancy at all costs. But MongoDB? Yeah, it plays by a completely different set of rules.
And this right here, this is the key mindset shift. What if, instead of just trying to stamp out every bit of duplication, our main goal was to structure the data to perfectly serve our application's needs?
This single idea is everything. Letting your application's needs, how it reads and writes data, drive your design choices. And that right away forces us to make a pretty fundamental decision. This is it, the central choice in MongoDB modeling. Do you put everything together in one self-contained box, or do you create a whole network of connected boxes? Let's break down that first strategy.
First up, we've got embedding. You can think of this as the all-in-one approach. It's a form of denormalization where you intentionally keep related data together in a single document.
So, for example, think of a product document. Instead of having reviews in a separate table, you just have an array of all its reviews sitting right inside that one product document. Everything you need for the product page, all in one place.
So when is this the right move? Well, embedding is absolutely perfect for what we call one-to-few relationships. Think about a user and their 5 shipping addresses. You'd use this when that child data is almost always needed with the parent. And, this is crucial, you know that data isn't going to grow uncontrollably forever. And the trade-off is pretty straightforward. On one hand, you get these incredibly fast reads, just one query, and your updates are atomic, meaning they're guaranteed to be consistent. But on the other hand, you're always up against a very specific, very hard limit.
And this is that limit, 16 megabytes. So if your embedded data is unbounded, like a super popular product that could get thousands and thousands of reviews, embedding is just the wrong choice, period.
Okay, so what if you have high-frequency data, but you don't want to create millions of tiny little documents? For that, we use a really clever technique called the bucket pattern.
Just imagine a sensor that takes a reading every single second. Now, instead of creating 3,600 tiny documents every hour, you create just one document, an hourly bucket, that holds an array of all 3,600 of those readings. The performance win from this is just massive. All right, now for the complete opposite approach. If embedding is all about putting things together, referencing is all about keeping them separate but connected.
So going back to our examples, a book document wouldn't contain all of the publisher's information. Nope, it would just store the publisher's _ID, which then links or refers to a separate document in the publisher's collection.
Referencing is your absolute go-to for any large-scale one-to-many or many-to-many relationships. It's perfect when that related data has its own identity, and you often need to access it on its own. Plus, it keeps your documents nice and small, completely dodging that 16 MB limit.
The trade-off here is crystal clear. You gain basically unlimited scalability, and you avoid data duplication, but it comes at the cost of read performance. Why? Because now you have to make multiple queries, or a dollar lookup, to kind of join that data together from different collections.
So, the big question, how do you decide which one to use? Well, it really all boils down to one core principle. Let this be your North Star. Honestly, your application's data access patterns are by far the most important factor in making the right architectural choice. Think of this table as your ultimate cheat sheet. Just look at the criteria. Let's say atomicity is critical, meaning you absolutely have to update a product and its inventory in a single all-or-nothing operation. Well, the table points you straight to embedding. But if that related data is massive or unbounded, you follow that row over to referencing. Use this to guide every design choice you make. But hey, what if you need a middle ground? It's not always one extreme or the other. Let's look at a few clever hybrid solutions that give you the best of both worlds.
This is a really cool one. For example, a product document might embed just the 5 most recent reviews. That gives you super fast page loads.
But all 5,000 reviews? They live in a separate reviews collection, ready for when a user clicks See All.
This is a fantastic performance trick. You embed just that tiny piece of data you need most often, like a publisher's name, while still referencing the full publisher document elsewhere. But there's always a catch, right?
Think about it for a second. You've now duplicated that publisher's name across hundreds, maybe thousands of book documents. If that name changes, it's now up to your application logic to find and update every single one of those copies to keep your data consistent. And finally, a really practical tip. As your application evolves, your schema will too. It's just inevitable. A fantastic pattern to manage this change is schema versioning. By simply adding a schema version field to your documents, your application can intelligently handle older document structures and migrate them over time without anything breaking.
At the end of the day, there is no single best answer. The perfect data model is never about blindly following a rigid rule. It's about deeply understanding your application's unique needs. The right choice depends entirely on your specific use case, and now you've got the framework to make that choice deliberately and effectively.